When it comes to studying data, one very interesting saying comes to my mind, and this probably sums it up all. It's by William Edwards Deming, probably the most famous business consultant of all times. We'll probably talk about him in this class quite a bit. He said, "In God we trust. All others must bring data." He couldn't have said it better. Data is at the heart of a lot of business decisions. But it's kind of hard to define what data is. What is data? Are numbers just the data? Or, it's more to it. And to encompass just what it is and to take out what it is not. A very, umbrella definition is every facts and figures that's collected, that is to be analyzed and summarized for interpretation. The idea is anything you can collect that can be used to say something about the scenario you're trying to analyze consists of. What is more important in the definition of data is the variable, actually. What is variable? Right. This is the characteristic you're interested in. Right? That's the first part. It's the characteristic you're interested in. The second part that's pretty important is it has to be able to take different values. It really doesn't make sense if all of your items take the same value. So for it to be a variable, it's something you're interested in, and it can take different values. And I'll let you look through the definition and try to understand it. Read through it, and it'll make a little bit. Let me walk you through the definition here. So this is the data for Dow Jones Industrial Index of the companies. Dow Jones is really the top 30 companies collected by Dow Jones, and that is sold that is traded in America. And the index is reported. It has been reported since 1930. So there's a long time series of it. So currently, the Dow Jones companies are Alcoa, American Express, Boeing, and whatnot. All right. So this whole thing is data. But this whole thing is data. The symbols, industry, share price, volume, the things that I'm interested in, that's what we call variable. Right? This first column here is the index. Right? You could really have called this an index too because it's separate, but let's think of this as variable for the time being. For Alcoa, this is the symbol, this is the industry, this is the share price, this is the volume. These are our observation. The definition, the way, the kind of a philosophical definition it works out is, for Alcoa, the symbol could have been anything within the range, and we chose AA. Well, we didn't choose, somebody else chose. It could have taken the value of many available values, say manufacturing, financial, technology, or something of the sort, and the value happens to be manufacturing. This kind of explanation, this philosophical explanation, is much more makes much more sense when the observation is numerical. The share price could have been anything. It is 8.03. The volume could have been anything, and this is the number. This way of looking at things is rather important. Later, which is the most of the case in data set, when we talk about things like random value, is a quantity whose values are not known with certainty. Another way of things is it could have been anything, and it happens to be that. That for me, for the time being, for that observation, it happens to be the value that we observed. That is a very important feature. That to be a random value, you cannot know what the value is going to be before you observe it. That's a very important thing, and that's at the heart of a lot of statistics we do. So okay, this is what variable is, and that's what observation is. Now let's go a little further. Again, very simple detail, very simple things that you probably have learned before. Population in the context of data means all the elements of interest. Suppose you're collecting the price data for stocks. For it to be a population, our previous data to be a population, what would have to happen is you have to collect all this information for every stocks out there. Now, how do you define every stocks? I mean, is it only the one that is sold in American exchanges, or depending on how you define it? But suppose if you have defined the stock as the one that is bought and sold in American exchanges, you have to include all the stocks there. That's population. Population is every element in the interest. Most of the time, you don't have access to the population. No matter what kind of data analysis you're doing, we only have a subset of population. Right? That's what we work with. We work with a subset of the population. And this is where the idea of random sampling again comes back again, and this is a lot of statistics is based upon. For you to be able, let me go back a little bit here. What we do is, in a statistic, we analyze the sample, that subset that we talked about. In the earlier case, instead of looking at every stock, there's thousands and thousands of stocks sold in American stock, we chose those 30, right? And we analyze those 30, and we make a statement about the whole population. Very important. We analyze the sample, but we make a statement about the population. For us to be able to do that, actually Dow Jones is a very bad example of it because we didn't take a random sample, we took the top 30. In most cases, for us to be able to make a statement from by studying sample and make a statement about population, you have to take a random sample. What I mean by this is, suppose you are studying something about all your clients. Things like, okay, how much do they spend every time they visit the shop? To get the information about everybody who came to your shop in last, 10 years, that might be a lot of work. So what you would do is you randomly choose, say, 1,000 people and make a statement about them. You don't control who those 1,000 people would be. You randomly chose it. It could have been anybody. It could have been somebody who spent $1,000. It could have been somebody who spent only $1. But the idea is if you take big enough sample, it evens it out. That is the only way you can make a statement about population. That's why this idea of random sampling is important. Now, quantitative data are where you can do numeric and arithmetic operations. Categorical data are the one which you can't add, multiply, subtract, and all this numerical manipulations. That's how we. So the real big important thing is mainly there are two kinds of data: quantitative and categorical. We'll focus on quantitative for the most part, and the idea is most of the times we don't have access to population. What we have is we have access to sample, and then we like to study it somehow, and we have to first make sure it was a random sample for the most part, and we like to study this sample and make a comment about the population. Cross-sectional data is you collected the data at one time. What I mean is, suppose you wanted to find the example that we looked at earlier, that was the price and the amount of stock sold on that day. Right? That day is important, that one day. It's at approximately in the same point of time all this data was collected. You wanted to find, say, how much money on average a state employee makes in this country, in this state this year. You collected the data for this year. That's cross-sectionally. The time is consistent along all your samples. Time series data is time is a variable. So you collected the price of a particular stock today, you collected yesterday, you collected day before yesterday, and going back like this, that becomes a time series data. Here, time is a very important component. We do a lot of work with time series data, and you have to. The main reason time series data is a little bit different than cross-sectional data is on time series data there is this dependency on what happened yesterday. What I mean is, Stock price is a random variable. Nobody's going to argue that. But Apple's price today is very, very correlated with Apple's price yesterday. But there is nothing to so there are two samples. But there is nothing that suggests my salary has anything to do with my colleague's salary. There is no real dependency there. So this dependency thing, this correlation, another mathematical way of saying things, causes a lot of difference between how we deal with time series data and cross-sectional data. And this is a good example of a time series data. Somebody's collected the data since starting 2002 all the way to 2013. How Dow Jones value has evolved over time. And this is what time series, it makes time series data, it puts data into perspective.